Hi, and thank you for coming. This talk is Customize Your App with MLKit, so I hope that's what you were expecting because we're going to get started. Hello, my name is Victoria Gonda. I am an Android engineer at Buffer, and in my spare time, I also help create learning content on Android and Kotlin on raywunderlich.com. You can find me on Twitter at ttgonda. That's where I have these slides posted as well as resources for this talk. So the question that we're answering here is, what is MLKit and how do I use it? So the TLDR is that really it abstracts some of the hard parts of machine learning specifically for mobile. It's an easy-to-use library without really needing to know how to do machine learning. So you have some data, whether that's images or text. You send it through MLKit, whether you're running it on the device or on the cloud, and then you get the results to use. It's as simple as that. And it means you don't need to know how to train your own models to do this. You can use the models provided by Google. MLKit is built on top of TensorFlow Lite. TensorFlow is a platform for building and deploying machine learning models. And it's meant to be an end-to-end platform that makes using machine learning easy. The Lite flavor of it is specifically developed for mobile and Internet of Things. So it's a bit smaller and more efficient for those kinds of devices. And then when you add the MLKit APIs on top of it, it can make it even easier to use using those provided models. So a couple things about MLKit. One is you can run it on both Android and iOS. I'm going to be using mostly Kotlin for Android examples, but you can also do Java on Android. You can use Swift or Objective-C on iOS. You can also run it on device or on the cloud. And you have some restrictions depending on the library, but some of them you have a choice. Some of the benefits of running it on device is you can kind of choose when you download the model. You can download it lazily just whenever you need it. This is good if you might not need the model, depending on what features the user uses. Or you can download it ahead of time so that it's available almost right away and you don't have to wait for any network connectivity or anything later. So it depends on if you want that latency the first time you use it, if you're going to always use it. And then if you're using a custom model, you can just bundle it with the app if you're okay having that size in your app bundle. Having it on the device rather than it's on the cloud means that your processing is quicker. You don't have to make that network call to get the results back from the model. So you have reduced latency there. And because you're not making that network call, there's also increased privacy because you're not sending your user data over the network to use your machine learning model. Because it is on device, you probably want a smaller than usual model because on IoT or mobile devices, you don't have as much space. So with a smaller model, it might be a little bit less accurate. And while ML model or machine learning models do take up kind of a lot of space, the MLKit models tend to be quite small and optimized relatively, so you have to worry about that a lot less. And then if you're running it in the cloud, you can always make sure you're using the latest model. You also have like some options for A/B testing, and you might have that option if you're downloading from the device for local as well. If it's on the device, or on the cloud rather, you don't have to worry so much about size because you're not storing the model on the device. It's in the cloud someplace on a server. So with not worrying about size, you can have a bigger model, have a little bit more accuracy, but you do have more latency, partly if your model's bigger, more complex, and because you have to make that network call. And again, with that network call, you have to be concerned about, are you sending sensitive data over the network? And this is just like a quick table of all of the different APIs available. Some of them you can run on device, some of them on the cloud, some of them both, and it's your choice. So if you decide to use MLKit and you're trying to make that decision, this will be helpful for you. So the MLKit APIs come in two categories, and we'll go over each of these items in a bit more detail. The first are the vision APIs, and these are for photos or video streams. So basically, you get some information about a photo, usually like what's in it. This is also where you have options for customization to use your own model. And then there's the language APIs. These are newer than a lot of the vision APIs. Most of them are around what the language is itself. And then there's also one for messaging. Eric gave a really good talk on MLKit last year, so I won't go into as much depth into the APIs that he specifically talked about, and I'll let you know which ones those are when we get up to them. If you want to know more information about them, I encourage you to watch his talk. It's pretty great. But know that the APIs are pretty similar across the different APIs, so if you know one, it'll be pretty easy to pick up the other. So to get started, we're going to start with vision APIs. In this, the input is a photo or a video stream. And we're going to look at object detection and tracking. So this is one of the newer vision APIs. You use it to find prominent, like a prominent object or multiple prominent objects in the image. So you can find up to 5. If you're using a video stream, you can track the location of the object across multiple frames of the video. And this is all in real time as well. You get the coordinates of where the object is in the video. And you can also opt in to get a broad classification of what the image is, such as food or a plant. One application that this could be helpful for is a visual search. But there are so many others too, and we'll talk about another one of them later in this talk. So for all of these APIs, you need to make sure your app is set up with Firebase. This includes going to the Firebase console, setting up your app through like the wizard, downloading a services.json. Pretty much the same thing you do with any of the Firebase APIs, and there's really good walkthroughs of how to do this. So I won't walk through a wizard up here. And then you also have to apply the Google Services plugin. And then the MLKit dependencies. We have the ML Vision dependency, since this is a vision application, and we're doing the object detection model. And then in the code, first you have to decide how it is that you want to use it and tell MLKit what options you want to use. For this API, there's a couple things that you get to decide. First, you decide if you are sending a video stream or a single image. Here, we're setting single image mode. Stream mode is the default. This is if you are streaming a video. The stream mode has less latency, but it can be less accurate too, especially for the first couple of frames. And then the default mode is the stream mode, so if you don't want to change it, you can leave this off if you want. And then, because you have the option to detect the single most prominent image or multiple prominent images up to 5, you can enable multiple objects. The default is to just track the single most prominent object. And then finally, you can opt in to have that coarse classification of what the object is that's detected. These coarse categories are like fashion goods, food, home goods, places, plants, and then it also has unknown if it's not sure what classification it's in. And then finally, you build it. The next step is that you get a detector using those options that you just created before then. The options are optional. So if you want to go with all of the defaults, you can just leave that parameter empty and it'll just work with the defaults. And this pattern that you see here, and as we continue to walk through, is a pattern that you'll see all over the MLKit APIs. It's pretty consistent, and you'll see that pattern emerging as we go through some of the other APIs. Then you wrap your image in a Firebase Vision image. Do note that with this, rotation matters, and there's guides in the MLKit documentation to show you how you can make sure your image is rotated the right way. There's also more than just from bitmap to wrap this image. It just worked nicely on the slide. And this is something that you need to do for any of the Vision APIs. So this knowledge will carry over to the other Vision APIs that you might want to use. And as I mentioned, there's multiple different ways you can wrap that image. I was using from bitmap on the previous slide, but you can do media image, byte array, byte buffer, file path, and there's examples of all of these in the documentation. And then finally, the fun detection part, now that we have all of the setup done. To do the detection, you simply call process image on the detector. You have a success listener to handle the result, in this case, the detected objects or object. And then a failure listener in case it didn't work for some reason. In the success block, there are a few bits of data that you get. One is a bounding box, which gives you the coordinates of the object that was detected. So this might be nice if you want to put like a box around the object that's detected, especially if you're doing a video stream. If you are using a video stream so that you can track the object across frames, you get an ID for that object. And you can use that ID to know if the object that you're looking at is the same object as you got returned in the previous frame and if it's moved. With classification enabled, you get that classification category. Remember, this is just a very broad category. And you also get the confidence of that classification. The API is really similar if you're working with Swift on iOS. So you create the options and set the properties. You create the object detector and wrap the image in a Vision image. And then process the image with a callback. I'll be doing the rest of the examples in Kotlin for Android, but know that you have the options to do Java for Android, and then Swift or Objective-C for iOS. And with that, you can customize an app to help you detect where something is in the image. So now we know where my hedgehog is in that image. All of the Vision APIs follow the similar pattern. You have options to create a detector. Sometimes the detector has a different name, like identifier. Wrap your image in a Firebase Vision image and process your image to get the results. Because of that, I'm not going to show the code for the other Vision APIs. So if you want to see the code for that, I encourage you to look at the docs or watch Eric's talk from last year. So the first of those is barcode scanning. And you can use the barcode scanning API to get data encoded in barcode, and it supports most standard formats. You can use it to pass data into your app, automatically parse it, and do something with that data. They recently released a new version of this API with improved latency and accuracy, and it also supports another barcode type. There's also face detection. With this one, you can find if and where there are faces in an image, as well as some facial features. You can get the contours of the detected faces. And you can use this for all sorts of things, from like fun things like editing photos with facial landmarks, but you can also use it to respond to facial expressions. The next one is image labeling. You can find out what's in an image, like specific people, things, places, activities. With this, you also get the confidence score of how confident it is with that label. You can use this for all sort of things, from like sorting and labeling images. I played around with it from things like suggesting alt text to coming up with suggested hashtags. And this is one of the ones that you can perform it either on device or in the cloud. There are so many applications with this, and we'll look at the end of the talk about ways to customize this. Very similar to the image labeling is landmark detection. So this is like image labeling, but specifically for well-known landmarks. So you'll get the name of the landmark, but also the location of where the landmark is in the world. You could use this for something as simple as storing image metadata to make images easier to look for. I could also imagine some really great travel applications. And you can use it to tailor your content based on locations that maybe your user has visited or is interested in. The final specific Vision API that I'll bring up right now is the text recognition API. For this, you can recognize a number of different languages. The number of languages available depends on if you're running it on device or on the cloud. If you're running it on the cloud, you're going to have more accuracy. It's going to be able to detect text in more languages. From an image, you can get the text and where it is located in the image. This can help with data entry, so instead of having to manually type everything in, maybe you can take a photo of a document. You can also plug this into a translation API that we'll look at later to help with language barriers. And it's because you know the location of the text, you could even overlay the translated text on top. One fun thing that I did with this API, just kind of playing around with it, is I made a little app that you can take a photo of a conference slide. It'll look to see if there's any Twitter handles on it, and it will find that Twitter handle for you so you can open the profile, look at the profile, follow the person if you want. That's the end of the Vision APIs that we're looking at right now. All of these are great ways to tailor your app to make your app more fun, easier, more enjoyable for your user, and they all follow very similar APIs. What's fun with these is with the Vision APIs, they also work pretty nicely with Camera X. And I won't go into much detail about that now, but know that there are some great resources on how to integrate them on Android. So with that, we're going to hop over to the language APIs, and we're going to look in detail into all of these. These things have to do with text as your data rather than images. And the first one is language ID. So with any string, even a pretty short one, you can determine with some confidence what the language is. This can be useful for determining the language your user is using to either translate content or give them an overall smoother experience. It supports 103 languages, and this is just another way that you can make your app have a customized experience for your user. As with all of these, you have to include the MLKit dependencies. For the specific API, we have the natural language dependency as well as the language ID model. We have an options builder again. You can see the pattern emerging. This one is for language identification, and really the only thing you need to set on it is the confidence threshold if you want to change that. For this, the default is 0.5, so if you're okay with 0.5, then you don't have to worry about the options. Then you get your identifier. This is the same step as getting the detector before. Again, the options are optional. So if you just want to go with 0.5 for the confidence, just don't include that parameter. Then, because the input is only a string, you don't need to wrap it in a Firebase object. You can just pass the string right into the identifier. And then you have your success and failure listeners. The result is simply a language code. UND is used if the language was not confidently detected. They have a list of the supported languages on their website, so you can see all of them there. If you need more control than this, you can use identify all languages instead of identify languages, and you'll get a list of all the detected languages with confidence scores, and you can decide what to do from there. Maybe that's using the detected languages to give your user an option. A lot of possibilities there. So with that, you can determine the language with even a small bit of text like this. So What's neat is you can use the output of this API as one of the configurations or inputs for the next API that we're going to talk about. And that's on-device translation. This supports 58 languages, and because it's on-device, the text never has to leave the device, so you don't have to worry about the privacy there. You can use this to translate content or improve communication between people across the globe. Some languages do translate better than others, so there could be some grammatical errors, but in most cases, you can get the point across with this translation. Here we have the dependencies, the natural language dependency, and the language translate model. Options builder again. For this one, you have to set the source language. If it's appropriate, you can use the result of the language ID API as the input for this setting. Here we're just setting it as Spanish. Then you also need to set the language that you want to translate into, so the target language. If it's more appropriate, this is another place that you can use the detected language from the language ID API. Or you can just set it explicitly like we do here to English. And then of course build. Then, as a similar step as before, this one we're getting the translator using the options just created. I'm pretty sure the options are required for this one, so don't leave it out. We need to know if we're translating from one language versus another language. What differs here is there's a download step. Translation happens on device, but each language has its own model. And it would kind of be a lot to store the models for every single language it supports on device. So instead, you need to download the model specifically for the language that you're looking for. If you know that you're going to need it ahead of time, there's an API to download it ahead of time, or you can do it just as soon as you need it. There's also an API to delete a model if you don't need it anymore. This is especially important if you're going to be using a lot of different languages. You want to try not to keep all of them on device at once, especially if you don't need them at that time, because that can start to get sizable. After it's downloaded, you can get to work on translating. As you might expect, this is done by passing the text in to the translator. We're seeing this pattern a lot. And then you can use the result and the success listener. The result is just the string of the translated text, so nothing fancy there. And there you have easy on-device translation. Again, you need to be a little bit careful if you know you're going to be dealing with multiple languages, just because you don't want too many models saved on the device at once. There's a download manager for both if you want to download models ahead of time or clean them up later if you know you're not going to need them anytime soon. For the last language API we're going to look at is Smart Reply. And you might have seen this in action if you've seen maybe suggestions to a text message that you received. And you can use it to generate suggested responses in a message chain. With it, your users can respond to messages more quickly with a simple response. It can also be really helpful on devices that have limited input capability. It uses the full context of the conversation and not just the last message, which makes the results a little bit more accurate than if it was just looking at the single last message. Makes it a little bit more usable that way. It's also smart enough to pay attention to if it's a supported language. Right now it only supports English. And it also stays quiet if it detects that it's a sensitive topic. If it's a sensitive topic, you probably don't want a machine-generated response. You want a human response. Again, we have our dependencies. Here we're using the Smart Reply model. Note also that you should make sure that the model isn't getting compressed when built. So we don't need to provide options here, so we're going to go straight into how we need to format the data to send it. because it's messages, it's not as simple as just a string of text. The format is a list of messages. They're to be ordered chronologically with the earliest timestamped message first. Then you can start adding messages to the list. There's 2 different types of messages that you can create, and it does matter which ones you use. You have the local user messages, which are messages written by the user whose device it is. It's in their hand, their type of messages. Then there's the remote user model. And these are the messages that are coming in from other people. With this, you also need to include the timestamp of when the message was sent. For a remote message, you also need to provide an ID for the user. This is for the case that there are multiple people in the conversation in order to keep the users distinct, if there's multiple remote users. This ID can be any unique string that you choose. It doesn't have to match up with your own models. It doesn't have to be consistent across multiple different conversations. It just has to be consistent within that conversation, just so that that user can be distinct. It is worth noting that suggestions are only given if the most recent message is from a remote user, so that there's something for the local user to reply to. Then you get your smart reply instance. This one you don't need to pass options to, so we didn't create any. And then you get going with suggestions. As before, you pass in the data, in this case, that list of conversations, or the list of messages that compose the conversation. In the success block, you'll get a result with the status that will tell you explicitly if the language is supported or not, as well as other statuses, such as if it's successful and there are suggestions there for you to display. And then, same as before, the error handler. Then you can show the suggested options to your user. I believe there are at most 3 suggested responses. So once there's a conversation, it can suggest some responses that your user can quickly tap and choose how to reply. If there are no responses, there are a couple reasons why this might be. It could be that there's simply no confident results from the model. It could also be that the language isn't detected as English, or if it thinks that it's a sensitive topic. Okay, we're going to jump back to the Vision APIs. This is because we're going to talk about how you can make this even more customized than using the Google models. For the Vision APIs, you can provide your own model, and it behaves similarly to the image labeling, but you can tailor the model to your specific needs for your app. This model could be something you create yourself, or maybe you get from the data team. And this is where like the real customization for your app comes in. The other things, yes, you can customize your app. This, you can make it even more customized with your own model. Through bringing this in your own TensorFlow models, you can really tailor your app to what you're doing with the images. And some benefits with using MLKit for this is that you can host the model on Firebase, update the model without needing to release, maybe do A/B testing with it. You can download the model on demand, lazily. With this, you can also bundle the model in your app if you prefer that, and you want it available right away, regardless of if there's internet connection. If you don't need all of the Firebase functionality of A/B testing and all that, TensorFlow Lite could be a better option. I personally enjoy using the MLKit library, so if I can get away with it, that's usually what I tend to do. And if no one on your team has the knowledge of how to create your own model, that's okay. You can still use this if you use AutoML Vision Edge. And with that, you can train models with your own data with almost no knowledge of machine learning. You can upload your data, go through a setup wizard, and then get your model. Your data is images and labels. So maybe you have an app that will match a dish that the user made to a recipe in their library. You format the data with folders, and the names of those folders are your labels. And then in those folders, you have photos that match that label. So here we have a folder called bread. So bread is the label, and then we have photos of bread in that folder. From here, it's mostly a wizard that you walk through so that it can crunch the data on Firebase. The hardest question to answer when going through this wizard is if you want to optimize for accuracy or speed or model size. And it's up to you to decide how you want to balance those things. Also, if you want to let it train for a longer amount of time or a shorter amount of time, a longer amount of time, it'll probably be more accurate. But you might have to pay more if you train it for a longer amount of time. You get 3 hours for free. After that, you have to pay. If you have too many images, that will also make it take longer. So larger data sets take longer to train. Once you have your model, you can use it in your app. You can choose to bundle it up in your app or download it on demand. The first has a larger app download, but you can use it right away without having to worry about internet connectivity. The second means a smaller initial app download, but you have to wait to download it later. Having it remote and downloading it on demand also means that you can update the model on the server without having to release new app updates. And we'll show both options here, how to do it, downloading it on demand or bundling it with your device or with your app. So starting with the model hosted on the cloud. You build the model using the name of the model that's set up in Firebase. And then you can use the download manager to download the model. You can do this right when you need it. You can do it ahead of time. You can also add conditions about whether you wait for Wi-Fi if you only want to download it while you're connected to Wi-Fi. Note that this is the same download manager that you can use with the translation API to control when you download models for different languages or delete them. Then you can asynchronously download the model if the conditions are met. If the model isn't on the device, if there's a new updated version. And you should always check if the model is downloaded before you try to use it. If you're bundling on the device instead, you take the files that you download from AutoML Vision Edge. This is the model, a dictionary file, a manifest JSON file, and you put them together in a folder under the assets directory. Because you're bundling with your app, you need to make sure that it's not compressed when the app is built. Then you use that to create a local model using the file path of the manifest JSON file that you downloaded and put in your assets directory. And then the rest of the steps that we'll look at here are the same for both remote hosting or bundled with the app. So as usual, you create your options. For this one, you pass in your model, be that your local model or your remote model. You also set your confidence threshold. You can look at the results from training your model in Firebase to help you decide what this confidence model should be. Then you use your options to get an instance of a labeler. And you should be familiar with this pattern by now at this point of this talk. You wrap your image with a Firebase Vision image. This is the same as before. There's multiple ways to do this. You can look at the documentation to see which option makes the most sense for your application. And then process the image. And I'm sure you could have guessed that. There are two things that you get in the response. One is the text. This is the label of what the labeler thinks is in your image. So for our example, we were looking at this will either be bread, cake, or pie. And then also the confidence for that label. We went on a journey of a whole bunch of different MLKit APIs. And you might have gotten the hint that you can even combine these to create an even more customized experience in your app. The most obvious of these is that you can use the results of the Language ID API to use in the Translation API. But you can also do a really cool thing with the object detection that we talked about first and this custom model that we talked about last. Sometimes it can be really hard to train a really good model that works for different backgrounds, especially noisy backgrounds. With the object detection API, you can find and detect that prominent object that you're trying to use in your and label in your custom API. You can crop around that detected object, and then you can send that cropped image to your model, so it doesn't have to worry so much about background noise when you're training it and using it. In fact, this is exactly what they're doing in the newest Barcode API. They're finding the barcode, cropping around it, and then scanning what's in the barcode. And they use this to make the Barcode Scanning API more accurate and have less latency. And I'm sure there's so many other applications too. And then before we go, I'm going to speed through some case studies. It's always really fun to see what other people are doing to help you get creative about what you could do yourself. I've mentioned I played with it to pull Twitter handles from conference slides, to generate alt text, or to suggest hashtags. I've heard of a lot of people using the Barcode Scanning API. And I'm constantly thinking of new ideas, and I love hearing your ideas as well, so feel free to come and just think of fun ideas for this. Until then, I'll share the couple of examples that are on the Google website. The first is Xyle. This is an app that brings back photo memories for you to share later on. And it uses MLKit to privately detect faces and memories and photos. And by using MLKit, they were able to do this with a smaller memory footprint, and it was just a lot easier to implement that machine learning. Another is Lose It, which is a nutrition app. One of their main features is a calorie and nutrition tracking feature. Through using MLKit, you can take a photo of the label and use that to enter the nutrition information instead of having to do it manually. And then whatever you may be doing in your app, you can use MLKit and machine learning in general to tailor to what your users need, make their lives more fun, make it more easier. You can do fun, entertaining apps, making data entry easier, facilitating conversations across languages and abilities. You can use it to verify documents before sending. Is this a check? Is this a receipt? So on. I mentioned the idea of trying to match a dish that the user cooked to a recipe. You can add relevant stickers and filters to photos and so many more things. And with that, I want to thank you all for coming and listening to this talk. I can't wait to hear all of your ideas. Feel free to come find me to ask questions about this. I'm also happy to talk about remote work. Or you can just come introduce yourself and say hi. I'd love to meet as many of you as possible. I have my slides and my resources up on my Twitter at @ttgonda. And then you can also find the resources at the link on the slides, bit.ly/VG-talks. And thank you.